uh, mapper in MyBatis. Uh, Now we are focusing on mapper. Mappers are interfaces that you create to bind to your mapped statements. Instances of mapper interfaces are acquired from the SQL session. As such, technically, the broadest scope of any mapper instance is the same as the SQL session from which they were requested. However, the best scope for mapper instances is method scope. That is, they should be requested within the method that they are used and then be discarded. They do not need to be closed explicitly, while it's not a problem to keep them around throughout the request. Similar to the SQL session, you might find that managing too many resources at this level will quickly get out of hand. Keep it simple, keep mappers in the method scope. Here you can see MyBatis lifecycle and scope. It is very important to understand the various scope and lifecycle classes. Using them incorrectly can cause severe concurrency problems. Dependency injection frameworks can create thread-safe transactional SQL sessions and mappers and inject them directly into your bean so you can just forget about their life cycle. You may want to have a look at MyBatis Spring or MyBatis Goose sub-project to know more about using MyBatis with DI frameworks. Here you can see MyBatis config.xml. Here you can see a SQL session factory builder. This class can be instantiated, used, and thrown away. There is no need to keep it around once you have created your SQL session factory. Therefore, the best scope for instances of SQL session factory builder is method scope. That is a local method variable. You can reuse the SQL session factory builder to build multiple SQL session factory instances, but it is still best not to keep it around to ensure that all of the XML parsing resources are freed up for more important things. SQL session factory. Once created, the SQL session factory should exist for the duration of your application execution. There should be little or no reason to ever dispose of it or recreate it. It's a best practice to not rebuild the SQL session factory multiple times in an application run. Doing so should be considered a bad smell. Therefore, the best scope of SQL session factory is application scope. This can be achieved a number of ways. The simplest is to use a singleton pattern or static singleton pattern. SQL session. Each state should have its own instance of SQL session. Instances of SQL sessions are not to be shared and are not thread safe. Therefore, the best scope is request or method scope. Never keep references to a SQL session instance in a static field or even an instance field of a class. Never keep references to a SQL session in any sort of managed scope, such as HTTP session of the servlet framework. If you are using a web framework of any sort, consider the SQL session to follow a similar scope to that of an HTTP request. In other words, upon receiving an HTTP request, you can open a SQL session, then upon returning the response, you can close it. Closing the session is very important. You should always ensure that it's closed within a finally block. Following is a standard pattern for ensuring that SQL sessions are closed. Try open bracket SQL session equal SQL session factory dot open session open bracket close bracket open curly bracket, and do the work and close curly bracket. Using this pattern throughout your code will config.xml file is connected to SQL session factory builder. SQL session factory builder is connected to SQL session factory. SQL session factory is connected to SQL session, and SQL session is connected to SQL mapper. Here you can see the structure of mapper file. The map file is a configuration file in XML format, which consists of a series of elements with hierarchical relationships, and through the attributes of element there is a correlation between these elements. The details are shown in this figure. In the map file of mapper, the main components are as follows. The mapper element, this element is the top level configuration element, and its attributes namespace point to the full type name of the IDAO class, namely the package path plus class name. Under the mapper element, it contains the following sub elements: result map element, select element, insert element, update element, delete element. Result map element establish a mapping relationship between listing of the database table and data fields of PO category. When the data fields of PO category are inconsistent with the database table, or when carrying complex query result, use result map configuration. Select element used to maintain select sentences statements. Insert element used to maintain insert statements. Update element used to maintain update statements. Delete element used to maintain delete statements. Here DAO is connected to two parts, and here it's connected to namespace. Here the mapper is connected to namespace, and namespace is connected to here, and here ID is connected to here, and the mapper is connected to result map, select, insert, and update and delete. Here ID is connected to select, insert, update and delete. Here the result map is connected to type and ID. Type is connected to PO. Here select is connected to result map is connected to ID, and result here select is connected to result map, and this result map is connected to PO. Here select is connected to parameter type, and parameter type is connected to PO. Here insert is connected to use generated keys, key property and parameter types. Here update is connected to parameter type, and here parameter type is connected to PO, and here delete is connected to parameter type is connected to PO. Here you can see the mapper XML file have only a few first class element in the order that they should be defined. The true power of MyBatis is in the map statement. This is where the magic happens. For all of their power, the mapper XML are relatively simple. Certainly, if you were to compare them to the equivalent JDBC code, you would immediately see a savings of 95% of the code. MyBatis was built to focus on SQL, and thus it's best to stay out of your way. The mapper XML files have only a few class elements in the order that they should be defined. Cache configuration of the cache for a given namespace. Cache ref, reference to a cache configuration from another namespace. Result map, the most complicated and powerful element that describes how to load your object from the database result set. Parameter map deprecated. Old school way to map parameters. Inline parameters are preferred, and this element may be removed in the future. No, not documented. Also, SQL, a reusable chunk of SQL that can be referenced by other statements. Insert, a mapped insert statement. Update, a mapped update statement. Delete, a mapped delete statement. Select, a mapped select statement. Here you can see a mapper mechanism. When using a mapper interface, the developer can execute SQL only by creating a mapper interface and mapping file. When executing an application, implementation class of mapper interface is generated by MyBatis 3 using the proxy function of JDK. Hence, the developer need not create the implementation class of mapper interface. It is not necessarily to define inheritance and annotation of interface provided by MyBatis for mapper interface, and it can be simply created as Java interface. Example of Java interface. As an The process flow up to SQL execution when mapper interface method is called is shown below here. The mapper mechanism is shown here. One application calls the method defined in mapper interface. The implementation class of mapper interface proxy object of mapper interface is generated by MyBatis 3 component at the application startup time. 2. The proxy object of mapper interface calls invoke method of mapper proxy. Role of mapper proxy is to handle the method calling of mapper interface. 3. Mapper proxy generates a mapper method corresponding to the called mapper interface method and calls execute method. The mapper method plays a role of calling SQL session method corresponding to the called mapper interface method. 4. Mapper method calls SQL session methods. When SQL session method is called, a key hereafter referred as statement ID is passed in order to specify SQL statement to be executed. 5. SQL session fetches SQL statement from mapping file using the specified statement ID as key. 6. Session sets the value of the bind variable specified in the SQL statement fetched by mapping file and execute SQL. 7. Mapper interface SQL session converts SQL execution results to Java bean, etc., and returns to the application. When number of records or number of updated records are to be fetched, primitive type or primitive wrapper type, etc., form the return values. Statement ID is the key to specify the SQL statement to be executed. It is generated accordance with the rule FQCN of mapper interface plus dot plus name of the called mapper interface method. When SQL statement corresponding to the statement ID generated by mapper method is to be defined in the mapper file, it is necessary to specify FQCN of mapper interface in the namespace of mapping file and method name of mapper interface in ID attribute of various statement tags. Here you can see application service, mapper interface and mapper proxy are inside JDK proxy. Here mapper method, SQL session, mapping file and database. Here one application service is mapper application service is connected to mapper interface via call method, and mapper interface is connected to mapper proxy via invoke 2, and 3 mapper proxy is connected to mapper method via execute. Then mapper method is connected to SQL session via insert, update, delete, select, xxx, and SQL session is connected to mapper file via find SQL statement. Mapper file is connected to SQL session via SQL statement, and then SQL session is connected to database via execute SQL statement, and SQL session is connected to application service via type safe object. Here the mapper proxy, mapper method and SQL session are provided by MyBatis 3. Mapper interface and mapping file is mapping file implements by developer. Um, Now we are considering a mapper execution process. SQL session component, which is a user level API. Users can use SQL session to obtain desired mapper object. Mapper proxy object. When executing the mapper method, mapper proxy will create a corresponding mapper method, and then bottom layer of mapper method is actually a SQL session to execute SQL, but it should be the executor component that actually execute SQL operations. Executor can be understood as a SQL executor which uses statement handler component to operate on JDBC statement object. When the statement type is callable statement and prepared statement, the parameter placeholders will be assigned assigned values through the parameter handler component. Parameter handler component will find the corresponding type handler object according to the Java type, and the type handler will set the value for the parameter placeholder in the statement object through set xxx method, such as set string method provided by the statement object. After statement handler component uses the statement object in JDBC to interact with the database. When the SQL statement type is select, MyBatis obtains the result set object from the statement object through the result set handler component, and then converts the result set object into Java object. We can use diagram to describe the relationship between core component. Here SQL session execute a statement handler, parameter handler, result set handler, type handler, and configuration are in MyBatis section. Here under JDBC, here result set statement, prepared statement, and callable statements are there. SQL session interacts with executor interacts with statement handler. Statement handler is connected to parameter handler and statements here, and parameter handler is connected to statements, and type handler is connected to statements here, and statements are connected to result set here. Here statement, prepared statement, and callable statement. Result sets is connected to type handler and result set handler. Type handler is connected to result set handler here. Result set handler is connected to statement handler. Here you can see mapper proxy. In MyBatis, our DAO is dynamically proxies through mapper proxy. That is to say that when we execute the method in DAO written by ourselves, the corresponding mapper proxy is actually acting as proxy. Here you can see default is SQL session, actor, configuration, mapper registry, and mapper proxy factory. Here one configuration is connected to mapper proxy via get mapper class SQL session. Mapper proxy is connected to then mapper registry. Mapper registry is connected to mapper proxy factory. Mapper proxy factory is connected to itself by a new instance. Mapper proxy factory is connected to mapper registry via return mapper proxy. Mapper proxy registry is connected to configuration via return mapper proxy. Configuration then actor is connected to default SQL session via get mapper class. Default SQL session is connected to configuration via get mapper class. Configuration is connected to default SQL session via return mapper proxy. Default SQL session is connected to actor via return mapper proxy. Now we are considering mapper responsibility. Here you can see some method signatures and how they are mapped to SQL session. Mappers are interfaces created by users to bind SQL statements. Insert, update, and insert, update, delete, and selects methods. Delete, select, and select methods are all powerful but also a bit cumbersome. A more general way to use the mapper class to execute the mapping statement. A mapper class is an interface class that only needs to declare methods that match the SQL session methods. MyBatis abstract each mapper node in the configuration file as a mapper interface, and the method declared in the interface corresponds to the select, update, delete, and insert node in the mapper node. That is, select the ID value of select the ID value of the update, delete, insert node is the name of the method in the mapper interface. And the parameter type value represents the input parameter type of the corresponding method, and the result map value correspond to the return value type represented by the mapper interface. So element type of the return result set. MyBatis will generate mapper instance through a dynamic proxy mechanism according to the method information declared by the corresponding interface. MyBatis will determine the statement ID according to the method name, and the parameter type of this method, and then map it to the map it with the SQL session, and the bottom layers to complete the interaction with database through the SQL session. This example shows some method signatures and how they are mapped to SQL session. Note the mapper interface does not need to implement any interface or inherit from any class, as long as the methods can be uniquely identified with the corresponding mapping statement. Mapper interface can inherit from other interfaces when using XML to build the mapper interface ensures that uh, statements ensure that statements are contain the appropriate namespace. Moreover, the only restriction is that you cannot have same method signature in two instances. Two inheritance interfaces, potentially dangerous practice are not advisable. So here xx dot mapper dot entity manager dot java interacts with xxx mapper dot entity mapper dot xml. Alias for the parameter that will be passed into the statement. This attribute is optional because MyBatis can calculate the type handler to use out of the actual parameter passed to the statement. Default is unset, and result type, the fully qualified class name or alias for the expected type that will be returned from this statement. Note that the case of collections, this should be the type of collection contains, not type of the collection itself. Use result type or result map, not both. This example shows using @select key annotation to retrieve a value from a sequence before insert. Here annotation insert, the annotation that specify a SQL for inserting records. Here this value returns an SQL for inserting records here. This block mapper is in package org.apache.ibatis.domain.block.mappers. As an example, now we are considering annotation interface mapper, marker interface for MyBatis mappers. This is in the package org.apache.ibatis.annotations. Now mappers, for example, here. Now that the behavior of MyBatis is configured with the configuration elements, we are ready to define our mapped SQL statement, but first we need to tell MyBatis where to find them. Java doesn't really provide any good means of auto discovery in this regard, so the best way to do it is to simply tell MyBatis where to find the mapping files. You can use class path relative resource references, fully qualified URL references, including file : / URLs, class names, or package names, for example here. Here using class path relative resources, using using URL fully qualified paths, using mapper interface classes, register all interfaces in a package as mappers. Now we are considering mapper XML files. For all of their power, the mapper XML files are relatively simple. The true power of MyBatis is in mapped statements. This is where the magic happens. For all of their power, the mapper XML files are relatively simple. Certainly, if you were to compare them to the equivalent JDBC code, you would immediately see a savings of 95% of the code. MyBatis was built to focus on SQL, and thus it's best to stay out of your way. Mapper XML files have only few first class elements in the order that they should be defined: cache, ref, result map, parameter map, duplicated, SQL, insert, update, delete, select. Now we are considering using mappers in mapper XML files. The following example class demonstrates some method signatures and how they map to the SQL session. Here the t get mapper class t type, while the various insert, update, delete, and select methods above are powerful. They are also very verbose, not type safe, and not as helpful to your IDE or unit test as they could be. We have already seen an example of using mappers in the previously. Therefore, a more common way to execute map statement is to use mapper class. Mapper classes. A mapper class is simply an interface with method definitions that match up against the SQL session methods. The following example class demonstrates some method signatures and how they map to the SQL session. In a nutshell, each mapper method signature should match that the SQL session method match that of the SQL session method that it's associated to, but without string parameter ID. Without string parameter ID. Instead, the method name must match the mapped statement ID. In addition, the return type must match that of the expected result type for a single result, or an array of or collection of multiple result or a cursor. All of the usual types are supported, including primitives, maps, pojos, and Java beans. Note mapper interface. Mapper interfaces do not need to implement any interface or extend any class, as long as the method signature can be used to uniquely identify the corresponding mapped statement. Note mapper interfaces can extend other interfaces, but sure that you have the statement in appropriate namespace when using XML binding to mapper interfaces. Also, the only limitation is that you cannot have the same method signature in two interfaces in a hierarchy. A bad idea anyway. You can pass multiple parameters to mapper method. If you if you do, they will be named by the literal param followed by their position in the parameter list by default. For example, hash param 1, hash param 2, etc. If you wish to change the name of the parameters, multiple only, then you can use @param name annotation on the parameter. You can also pass row bounds instance to method to limit query results. Here author select one. Here author select one, select author 5 here. Here list author, select list and select authors. Here map integer author. Select map, select authors ID. Here insert author and author. Here update author, delete author 5 here. Now we are considering pluggable scripting language for dynamic SQL. Or in case you are using mappers, using @lang and annotation. Annotation interface lang, the annotation that specify a language driver to use. This is in the package org.apache.ibatis.annotations. Starting from version 3.2, MyBatis supports pluggable scripting languages, so you can plug a language driver and use that language to write your dynamic SQL queries. You can plug a language by implementing following interface. Once you have custom language driver, you can set it to be default by configuring it in mybatis-config.xml file. Instead of changing the default, you can specify language for any specific statement by adding lang attribute as well, lang attribute, and or in the case you are using mappers, using @lang annotation. Note, you can use Apache Velocity as your dynamic language. Have a look at the MyBatis-Velocity project for the details. All the XML tags you have seen in this. Now we are considering configure logback in step 2 in logging configuration. Suppose you want to enable log for this mapper. Create a file called logback.xml as shown here and place it in your class path. This file will cause log slf4j logback to report details login for org.mybatis.example.blog mapper, and just errors for the rest of the class of your application. Here you can see a configuration example for log4j log4j2. Here you can see configuration example for log4j. Here you can see configuration example for JDK logging. Here the login.properties. Exception, we can consider binding exception. It's in package org.apache.ibatis.binding. As an error example, we can consider invalid bound statement not found. Now this is the end of my presentation. Thank you very much for watching it.